Okay, I'm going to share the screen now. Hopefully you can see this. All right, question 16. Hey, I saw some of the MCQ not done very well. So I got a shock, no, when I see so many red. I think y'all anyhow do. Didn't really think of how to answer the questions, right? Okay, question 16 here. Janelle, you couldn't access the worksheet, I see. Yeah, some of you actually came in very late. There was a worksheet, yeah. No worries. Don't panic, wait up. Just look at this question and see whether you can do this question or not, whether you understand the answers or not. Don't stress yourself. Good, Gordon, you have typed it in. Okay, what are the forces here? All right. For the wooden blocks to overcome in order for them to move. So what is this experiment about? There are wooden blocks tied to the pails. Then the blocks were placed on different surfaces, A, B, C, D. Roy dropped some coins into each container. So these pails, right, he dropped the coins in until the blocks began to move. Now, the number of coins required before the block can finish a certain distance, right? For A, it will be 22, B, 35, C, 18, D, 50. So the more coins required, the more difficult it was for the block to move on that surface. Y'all agree, right? So since that is the case, what can I say about this particular surface here? Okay, on this particular surface D, right? You see, this surface D requires so many coins before the pail can move a certain distance. So that means there is greatest friction between the surface and the block. Why I choose to let you all do this is actually, remember, don't tell me surface D provides the most friction. That is a wrong way of answering. Think about frictional force. Frictional force exists between two surfaces. A surface cannot provide frictional force. Are y'all clear? A surface cannot provide frictional force. Tomorrow, don't write down. Surface D has most friction. I'm going to faint if you write that, okay? So what force is required? Yes, this force needs to be overcome, right? So this is the force you need to talk about. Which is the smoothest surface. Smoothest surface means what? Something that only require very little force, okay, for any object to move on it. So smoothest surface, least friction. Okay, so talk about the selection here because C, container C is on surface D, right? So the number of points required to move the block was only 18. So make a claim and then you put down your evidence, okay? To put down your evidence. Why? Because you can also say the evidence can be only 18 coins, or you can say it requires the least number of points, right? So I saw many different answers being written. Very good. Okay, so talk about the least number of coins, etc., etc. I'm not going to write down the whole sentence. You get the idea, most important. Today is not for you to start copying a lot of these answers down. It is about understanding and we move on to the next thing. Every time you hear my explanation, you understand, we move on. You understand, we move on. Don't understand, I will clarify. Is it okay? Because we only have 1.5 hours and then you should be resting early tonight. Okay, so make a choice. C, you can put in the evidence, only 18 coins required, or it requires the least number of coins before the block moves the same distance. So therefore, reasoning, K requires the least force, there is least friction. So talk about least force required, indicating least friction present between the block and the surface. Okay? Any question here? No? Let's go on. Next, which surface do you think Roy should be using to make anti-slip tiles for a wet floor? Okay, especially toilet or kitchen tiles, right? Requires anti-slip tiles. Very important because these are the places where we have a lot of water present. Okay, so you don't want people to sleep, right? Then how do you answer this? Make a choice. Very good. Yes, the choice must be D. So you choose D. This is your claim. Okay. Then yes, I did see people writing down, okay, because 50 tiles or 50 coins are required to actually move the block over a certain distance. Okay, so that is the evidence. And then you talk about your reasoning. I will actually prefer the evidence to be the number of points, okay? And then this is the reasoning. So for this, talked about the points required for the, okay, block to move the same distance. Okay, so you continue on your own. So then reasoning is most friction between the block and surface D. Or you can also say, okay, this is an alternative answer. A person will need the most force in order to fall. Okay, like somebody must push him very hard. Yeah, before he can fall. Next, okay, Minnie pushed her toy car and it moved up the ramp. So this is the toy car. It moved up the ramp. It reached point S before it rolled back to point R. Describe the effects of forces on the toy car from when Minnie pushed the toy car to when it moved back to point R. So how do you answer this kind of question? Describe the effects of forces. What are the effects of forces? What are the effects of forces? Do you all still recall? Okay, forces involves pulling and pushing, right? So you can make something start moving, okay? Stationary objects start to move, change the direction of object, etc. So those are the effects of forces. Yes, change direction. Make something stop moving. Very good. Yes, increase the speed or decrease the speed. Good, Jia Ping. So yes, I see a lot of responses here. Answer accordingly. They are asking you to describe the effects. Okay, the effects of force. Okay, so the toy car started moving, right? But it stopped at S. Okay, and then it moved in the opposite direction or change direction or change speed because moving up is slower, moving down is a lot faster. Okay, so we all know that. So therefore, we did see that, okay, car started moving. Okay, and then because of her push mark, this is the force she has exerted. So she's caused this car to move, but the car stopped at S due to frictional force, right? So that's the effect of forces. Then it started to move in the opposite direction due to gravitational force pulling it downwards. So it will move in the opposite direction. So these are all the effects of forces. Clear? Can? Any questions so far? No? Good. Yeah, I need y'all to either shake your head or nod your head, give me a thumbs up or anything, okay? Quickly respond to me, then we can go on. Because I have another 100 slides to go through. Okay, 100 slides will be the notes. Now, in another experiment, Minnie coated the ramp surface with substance Z. She conducted the experiment again with the same toy car. But then now the toy car moved to point T. Instead of S, now it moved to T. Then after that, they ask you explain how substance Z caused the toy car to move a shorter distance. Why? What substance is this that caused the toy car to move a shorter distance? What do you all think? How would you answer this? Explain how substance Z caused the toy car to actually move this way. Okay, so let me see the answers that I'm seeing here. Okay, 17B. All right. Some of you wrote the wrong answers. Okay, so I can see your answers over here. Be very careful. Some of you are writing the wrong answer. So if the car can only move up to point T, tell me something about the friction. Yes. All right. Yes, that's correct. Okay. So what do you all write down? Let me see. Yeah. So look at this now. Answer is, so I saw the few of you writing things like, Gordon, be careful, don't say substance Z was rougher. Okay, substance Z caused the surface to become rougher. Can? That sounds better. But your idea is there. So there's more friction between the toy car and substance and the surface, not substance Z, the surface. Okay, cause more friction, good, cause more friction. Now, more gravitational force, substance Z cannot lead to more gravitational force because gravitational force is the pull of gravity from the center of the earth, Abil. Okay, unless we change planet, then we can have we can have different gravitational force. Okay, so substance Z increase the friction between the wheels of the toy car and the surface of the ramp. Can you see that? Increase friction between the wheels of toy car and surface of ramp, not and substance Z. So these are the few pointers you're got to be careful of. It's always between two surfaces. You just have to talk about surfaces, okay? So one surface is the wheels of the car, another surface is that of the ramp. Next, without removing substance Z, what do you think Winnie can do? Minnie can do if she wanted the toy car to move to point X. She wants the toy car to move to point X. What do you think you will do if you are Minnie? Okay, very obvious. Many of you said, give the toy car a harder push. Very good. So instead of pushing with the usual force, right? So now she needs to do what? She needs to make sure she is pushing this toy car harder than before. Okay? So she should give the toy car a harder push. Very good. Use more force to push the car. Yeah, I see that y'all have actually written. So Evan says she can add lubricant to the ramp to make the toy car reach point X. Do you think so? Can she actually put the lubricant on the ramp? Would you accept that? You will move downward faster. Okay. The car might slide down very fast.
Mouse.
Sorry.
You just tell me your
Okay.
mouse.
I think it was an accident, Isabel. Okay. But wouldn't it also go up faster? Okay, you will accept it, is it, Gordon? Okay, actually, it depends on how you reason it out as well. But if you put more force, don't you think it is going to make the car actually move up a lot faster? Yeah? I think can, right? Yes. Yeah. But need to be exam smart. Yeah. Correct. Cannot remove Z, but can he add lubricant? Avril, that is the answer that he gave. Okay, Evan says put some lubricant. But when you put some lubricant, it can move. If you put too much, lubricant, okay, the wheels can also skid and roll down because no grip. Yeah, so somebody said that earlier. Okay, the car might slide down too fast, so don't add too much. Yeah. So Evan, in certain cases, right, when they already have put something on the surface, you avoid adding another substance in, can? So you can say push harder. A lot easier because that doesn't have to do with putting things on the surface already. Okay, so instead of talking about surface, because they added something to the surface, now you don't add any more thing, don't remove anything, you just add more force. This is my best advice to you. Okay, next. Now, Minnie has two swim floats, A and B. She applied substance Z on swim float B before putting both floats on the water. Okay, her mother told her that by using float B, it would allow her to swim faster. Explain why the mother is correct. Explain why the mother is correct. Now, you see two swim floats A and B. All right, she applied Z on this swim float here before putting both floats on the water. Her mother told her that by using float B, it will allow her to swim faster. Explain why the mother is correct.
then you have to think of other methods, Tamai.